Hi, Morgan. Morning, Tessa.
Good morning.
Morning, Arissa. Just going to give her a couple minutes, girls, and I'm going to start with your assignment and go through it this morning. All right, we'll give her one more minute and then we'll get started. So if you have your assignments, that would be ideal. We'll go through your assignments this morning. All right, so looking at the absolute value. So what I do is I would simplify inside the absolute values first, starting with minus 9 minus 3. So that's a minus 12. 5 subtract 8, negative 3. Minus 7 add 1 is minus 6. Minus 6 minus 4 is minus 10. Okay, now I switch. All right, everything becomes a positive value now. So 12 subtract 3 plus 10. All right, 12 subtract 3 is 9. 9 add 3 is 19. Okay, so that was B in your first question. So I'll go through them relatively quickly. If you have questions, just ask. All right, if you need me to slow down and do something. It asks for the range. The range, f of x equals x subtract 3. All right, idea probably would be to graph it. We should know our range. Our range has to be all the y values, and we know that none of the y values can be below 0, so it has to be y is greater than or equal to 0. But if I was to graph it, I graph x 1, 2, 3, x minus 3, up 1, right 1. That's what I have as my original. My new graph, 1, 2, 3. Therefore, my range for this graph y is greater than 0, y is an element of all reals. So in this case, that was C. Okay. Then we have to solve for 1 minus 2x, the absolute value equals 9. So, again, we know that 1 minus 2x can equal 9, and 1 minus 2x can equal negative 9. Minus 2x is equal to 8. X is equal to negative 4. Minus 2x equals negative 10. X equals 5. And that answer was D. So 3 questions that weren't too bad to start the assignment off. Consider the function f of x equals the absolute value of 2x subtract 4. Okay, so f of x equals absolute value 2x minus 4. Oh. All right. Okay, 0, negative 4. Right here. Up 2, right 1. Right there. Okay, so the original graph, y equals 2x subtract 4. Now I flip it. And there I have the absolute value of 2x minus 4. It says determine the intercepts. The x-intercept is 2 and 0. The y-intercept in this case is 4. State the domain and range. The domain for this graph it goes left forever and right forever. Therefore, your domain is x to the element of all reals. Your range for this graph is same thing as always. Y is greater than or equal to 0. Y is an element of all reals. All right, then it asks for the piecewise for this. So the piecewise for this, y is equal to. So the first one is 2x minus 4. And the next one, minus 2x minus 4. Okay, so what part of this graph did I use? This is the 2x minus 4 graph. I used for x is greater than or equal to 2. For this graph right here, I use x is less than 2. Okay?
Mr. Newton,
Yeah, go ahead.
can you please repeat what the for 1, 2, and 3 what the what numbers they were? Just
sure. B, C, and D.
okay, awesome. Thanks.
Do you want me to show you the questions? I've got them up here.
No, I saw you do them, but then I couldn't see, and I was texting some people, and they didn't know if it was BDD or BCD, so I just thought I'd ask.
Okay, no worries. Yeah, the second one's C. It's greater than or equal to in number 2, and then D is the negative 4 and 5 one for 3. Okay. All right. Okay, so that's the absolute value of a line. Number 7, it says solve algebraically. Okay, so I have 3x squared minus 4 equals 4x minus 2. All right, so now what I'm going to do in this case is I'm going to let 3x squared minus 4 equal 4x minus 2. And then up here, I'm going to go 3x squared minus 4 equals the negative of 4x minus 2. We'll simplify this one first. 3x squared minus 4x minus 2 is equal to 0. All right, so I have minus 6, and I don't think this guy is factorable. Oh, I got an error here. Sorry, I wrote the question wrong. That's an x. That would make that a minus 5x subtract 2. Now I got it. Okay, and then an x up here. All right, so this one is factorable now. All right, 2 sets of brackets. I need a 3x here, a 1 here, an x here, and a 2 here. Okay, now I know that 3x and 1x are the only possible factors of 3. And I know that 2 is 2 and 1, and I need to get negative 5. So 3 times negative 2 is negative 6. 1 times x is 1x, so that gives me my 5x. So x is equal to negative 1/3 and 2. Let me make sure I did that right.
I didn't cause when I saw that 3x squared or whatever, so I thought it'd be easier if I just did the quadratic function,
Okay, yeah, which is okay.
Minus plus minus.
Yeah.
But then I think I got 1 and
2/3. Yeah, there was a number of you that got that.
That's the same as I got too.
Yeah, me too.
Yeah.
X equals 1x with 2/3.
3x times negative 2 is negative 6x. I saw that too. Just give me a second. Let me look at the work.
Or I guess technically I got 4/6, but then I reduced it to 2/3.
Yeah, there was a few of you that got that, and I was wondering where that came from. Oh, I don't have that answer here. Okay, do you have your work in front of you?
Yes.
All right, so let's see. What's the mistake here then?
Go ahead.
Oh,
Okay.
Plus 2.
Yeah, I'm going to tell you something, all right? This should be a plus 2 right here, shouldn't it? And if that's a plus 2, that's a game changer. That means then I need to have, all right, so if that's a plus 2, then that 2 has to go in there and the 1 has to go here, and they both have to be negative. So that gives me minus 3x and minus 2x, which is minus 5x. Minus 2 times minus 1 is plus 2. That's the error right there. So the answer is 2/3 and 1. I knew I'd change that somehow. Okay, so you got that. That one's right. Okay, and then up here, I have 3x squared minus x equals, I'm making a mess already here. Minus 4x, add 2, right? Add the 4x over, I get 3x squared. Looks like plus 3x minus 2 equals 0. And this is not factorable. So A is 3, B is 3, C is negative 2. And I'm just going to follow through here. So I've got x is equal to minus 3 plus minus square root. 3 squared, which is 9, minus 4 times 3 times negative 2. And all of that is over 2 times 3. Minus 3 plus minus square root. So that's 4 times 3 is 12. 12 times 2 is 24. Added to 9, that's 33, I think, over 6. And that I can leave as my final solution right there. All right. Now, I don't think either, I think only one of these works. So when I do this, I get minus 1.457 and 0.457. And I still don't know what I did with my my answers, but I think that only, just give me 1 second. I want to make sure I get this right. Oh, what the heck. I can't see it. So I think,
I'm not sure why you put in like brackets like negative for x minus 2, and then you added in the 4x, because when I did because when I tried to do the quadratic function, I took away 4x, and that's how I got 3x squared minus 5x plus 2. And then when you put that in A, B, C, you get it works out good.
okay, so in this one here, okay, so in that one, so in the first one, Amron, it is 4x subtract 2, so you subtract the 4x and you add the 2. In the second one, I have this negative in front because it's equal to the negative of 4x subtract 2. So when I transfer the negative through the brackets, I get negative 4x add 2, so therefore I have to add the 4x to the other side and subtract 2. Okay, and I think that this guy, one of these two didn't work. I think it was this one. I think he was outside my parameters.
I might have done it wrong, but for the second part, I tested them both and neither of them worked. And I have my work, but I mean,
yeah, I've got your work here too. Somebody else had the same thing. Yeah, neither one of these worked. That's right.
Yeah, I did that too. When I plugged it in for those in for X, they both didn't work. Yeah,
I actually have both your work right in front of me here. So yeah, I'm okay. Yeah. So that's what it would work out to. Amron, does that make sense what I said here with the negative?
There we go. Not really. I thought it's the same question. Is it not?
Well, okay. So let me do this just quickly different. So if I have the absolute value of x equals 8, right? Then that means that x can equal 8 or x can equal negative 8. You agree?
Okay, yeah.
So if I put 8 inside an absolute value, it's still 8. And if I put negative 8 inside the absolute value, it's still 8. Right? You understand that?
Yeah.
Okay. So what I'm doing here is the absolute value here can equal positive 4x subtract 2, or it can equal the negative of 4x subtract 2. So I have to do it. So I have to do it twice.
Oh.
Once as a positive and once as a negative. Okay? You follow that?
Yeah.
All right. Okay, and so that's how I end up. This second solution is with everything being a negative 4x subtract 2. And that's how I end up with something I can't factor. And this one, you did it right. You could use the factoring or you could use the quadratic formula. It works for the positive. It just doesn't work out nicely for the negative of that. All right? Okay? You got that copied down?
Yeah.
Okay. All right, so let's look at the next one then. Absolute value. Okay, so I need to graph both of these and find the intersection point of each of these. There should be two. Okay, so let's, I'll attempt to do it on here and then I'll do it on the Graphmatica so that it's cleaner than what I do here. Okay, so I'm going to graph the absolute value of 2w subtract 6 first. So y1 is absolute value 2w minus 6. So 1, 2, 3, 4, 5, 6 is right here. 1, 2, 3 is right here. Okay, and then I gotta go 1, 2, 3, 4, 5, 6. Up that way. So there is my absolute value of it. And I'm just going to, oh, I didn't mean to do a big guy, but I'm just going to erase this guy just so we don't confuse anybody. So I've got this right here. Okay, so there's the absolute value of that. Now what I want to do is I'm going to graph w plus 3. So y2 is equal to w plus 3. So 0 and 3, up 1, right 1. Just going to give me that. So I've got an intersection point here and an intersection point up there. This intersection point right here is 1 and 4. And this intersection point up there is 9 and 12. Okay, so just graphing the two lines. So let's have a look over here. Okay, so y equals absolute of 2x minus 6. And y equals 3 there. Okay, I don't know how well that shows up, but first intersection point is right here, 1 and 4. The next intersection point is up here, which is 9 and 12. Okay, so just that hopefully is a little bit better. All right, so that's another way in which we can graph an absolute value to solve for unknowns. Okay. And our last question, I believe. Our last question is absolute value x minus 4 equals x squared plus 4x. So again, this is a case where I'm going to do to the positive and to the negative. So x minus 4 equals x squared plus 4x. X minus 4 equals negative x squared subtract 4x. So I make them both negative on that side. All right. Subtract x, I get 0 is equal to x squared minus, no, plus 3x. Add 4. Oh, not factorable. That one's not factorable. And then up here I have, I'll move the x squared over. So I get x squared plus 5x minus 4 equals 0. Does that look right? Make sure I got those both right. Okay, so those are my two. Neither one is factorable. So start here. A is 1. B is 3. C is 4. X equals -3 plus minus 9. Subtract 4 times 1 times 4. Over 2 times 1 equals -3 plus minus -7 over 2. And that means that there are no possible roots there. Okay? Now, one of the things I want you to understand here is if I have 0 equals x squared plus 3x plus 4, that is a parabola that is above the x-axis, so it doesn't have any roots or x-intercepts. So that's why I end up with a solution that doesn't work here. So there's no possible answer for 0 equals x squared plus 3x plus 4. So now we're going to try it here. And I've got a equals 1, b equals 5, c equals -4. -5 plus minus 25 subtract 4 times 1 times -4 over 2 times 1 -5 plus minus the square root of 41, it looks like, over 2, and that works out to -5.702 and 0.702, and both of those work. Okay. All right, are there any of those assignment questions that you want me to explain? Cut out? Is there anything you want to see done or explained?
For question 9, I put everything on the left side and it was factorable for me, but I don't know if I did it wrong or not.
If you put for this one here,
Yeah.
you would have had a negative, a negative, and a negative if you moved them all to the left side. Do you have them all as negatives?
Yeah.
Okay, then you can't factor it, because in order to get a 3, you would need this +4 to be a -4.
Right.
Okay, because then you could do x add 4, x subtract 1. But if they're the same value, I can't do it. All right. If this is if it's x squared and it's a 4, the only way it works is if the middle term is +4 as well, because then you go x plus 2 and x plus 2.
Okay, I just wrote it out wrong. I must have done the adding wrong.
Yeah, could have been inside the brackets here. All right. Although you didn't use your quadratic function, so yeah, it would just, one of those two signs is probably incorrect.
Yeah.
Okay. All right. Is there anybody else that wants any of the other questions off of that assignment explained again? Okay.
Oh, I think I'm good.
All right. Thank you. Okay. So then let's have a look at yesterday's reciprocal assignment. Are there questions from that assignment? I expect there should be. This is not an easy thing to do. So are there questions on the reciprocal assignment that you want to look at this morning? Nobody has any questions from the reciprocal?
On page 323, number 11.
Okay. Yeah.
Sorry, I just flipped over to it here. I don't know. I'll look at it again. Actually, I don't know what my question was right now. I just have it marked, so I'll look at it and then yeah.
Okay. Anybody else have questions from that assignment? I'm a little leery that there aren't.
I'm just looking through right now. I know I had a couple questions like yesterday, but I didn't mark any of them, so just trying to find what I was looking for.
Okay. Yeah. No, take your time. Have a look. I just want to make sure that we cover that one because, like I said, reciprocals are necessary for next year. So we want to make sure that we've got this down. Okay. If that's the case and we're all completed that, then we should be into that review on chapter 7. So 7.1, 7.2, 7.3, 7.4. So the review has quite a few questions in it. So if we took today and tomorrow to do that review, today Wednesday, Thursday, so then Friday, I will get an assignment posted to you that we can that will wrap up the entire one. I will do a couple more questions off of the reciprocal than the other ones, just because we haven't really looked at them yet. So I'll try and get that prepped for Friday. So are there any other questions this morning from anything in chapter 7 that you want looked at or explained better today?
On the page 323, if you could just do like the first couple parts of column 3 on number 11.
Okay, so you want, well, why don't we, let's start by graphing it first, okay? So x squared subtract 3 means that 0 and negative 3 is my intercept, right? And the square root of 3 is where my x-intercepts are. So my x-intercepts so if you're looking at the x-intercepts for y equals, or f of x equals x squared subtract 3, they're plus minus root 3 and 0. So those are your x-intercepts. So now, when I take the reciprocal of that guy, you no longer have x-intercepts. So the first thing that you write in there are no x-intercepts because you have asymptotes on that graph. All right? I mark off 1 and 1 for that, and negative 1 is down here and right here. Now this point is key in the reciprocal because right now I have 0, negative 3. So when I take the reciprocal of that, it becomes 0 and 1, negative 1/3. Because I take 1 over the y of it. So my y-intercept for this question is negative 1/3. All right, so I go, now I shape it like that, shape it like this, shape it like that. Okay, so now let's fill in my my column there. My x-intercepts, none. My y-intercept is negative 1/3. My domain for this graph. Is how far left and right it goes. So I'm going to write it like this. X such that. X is an element of all reals. Okay? But X cannot equal plus minus root 3. So that's the trickiest part of this whole thing, is this domain and range. So the domain is X is an element of all reals. X cannot equal plus or minus root 3, because that's where those two asymptotes are at. The range for that graph, y is an element of all reals. All right? Now the range is a little bit trickier yet. All right? Because y can equal 0, but, so I'm going to take this, well, I'm going to write it like this. Y has to be greater than 0, and y has to be less than or equal to negative 1/3. That's a game changer right there. I don't have any y values in that gap right there between 0 and negative 1/3 and 0. There's nothing in there. All right, so the right way to write this range, which is something we haven't done much of, is all of the values are greater than 0, can't equal 0, and all of the values down here are less than negative 1/3. So that's my range. That's where I think that you probably see some difficulties in it. We don't need to really concern ourselves with piecewise function for this, because this is not two functions that we can create here. My invariant points, so same thing for my invariant points. I put 1 over x squared subtract 3 equals 1. 1 over x squared subtract 3 equals negative 1, and I would solve for both of them. So I don't know what they are. You'd have to use your calculator. Well, we could do it, I suppose. We could go 1 equals 1 over x squared subtract 3. X squared subtract 3 equals 1. X squared equals 4. X is equal to plus minus 2. So this guy is negative 2 and 1. This guy is 2 and 1. So there's two of the invariant points. And then the invariant points down here, all right, I would go negative 1 equals 1 over x squared subtract 3. Multiply it up, I get negative x squared, add 3 equals 1. Subtract. That would equal negative 2. X squared is equal to 2. X is equal to plus minus the square root of 2. So my invariant points down here, it's kind of messy, would be minus root 2 and negative 1. And this one up here would be root 2 and minus 1. So my four invariant points, Austin, are minus 2 and 1, 2 and 1, minus root 2 and negative 1, root 2 and negative 1. And then my asymptotes are at x equals plus minus root 3. So that basically covers that third column.
Okay, thank you.
Okay, so there's a lot of work in that. It's a lot harder for this guy. Okay. All right, anybody else have questions right now on anything in chapter 7?
So like, I've done like, I'm just kind of confused about that part. Like, I know another teacher said that, I just didn't really understand what's going on with all that.
I'm sorry, I missed the first part of your question, Amron.
I did, like all their assignments that we've done over this quarantine thing, they're just not going to count now, or
Okay.
I saw that.
I was going to get to that. All right. I don't know how to explain it, so I'm going to do the best I can as far as I know and how I'm going to approach this, Amron. All right. Now, in theory, the marks that you have done up to this point are not to be included in your mark average. Now, what they're saying is that we are not supposed to be designating marks to you. What we are supposed to do is we're supposed to do a formative assessment. So let's say your mark was 80, Amron, and I thought that, you know what, you've done pretty good work up to this point. I can say, well, she's met all of the requirements. I'd say I could lift her mark to 84, let's say. Okay? And that's what I put on the report card at the end. All right, so the lowest mark still is the mark that you had as of March 13th. That's the lowest possible mark you can have. Now, I'm not really sure how I'm going to do this. I want to keep giving you marks and posting them so that you can see them, so that when you're correcting, because I'm correcting on the board, I'm not correcting and sending them back to you. I want you to see those marks so that you know where you were at on that assignment. Okay? So I would like to register them. I don't know if I'm going to be able to. That's the only thing. Is if they're going to say to me, okay, no, you can't put those marks out there. But I want them out there. I want them so that you understand that this is how you're going to correct things. Okay? But they're not going to affect. There is zero effect on your mark as of March 13th is the mark you're going to have, and anything that you give me at this point, I am using it to either keep it at that mark that you had or raise your mark up. But it won't be based on stuff I don't know how to explain it a bit better. So let's say that you had let's put it this way. If you had every single assignment where your mark was less, okay, I would leave your mark at the mark that it is. If you have certain marks that are above it, and I feel like, hey, she deserves a couple better, some more, a better mark than what she had on March 13th, then I raise it. But it won't be an average of all the stuff that you're handing in. Okay? Does that make any sense whatsoever? Amron?
Yes.
Just shut your mics off except for Amron for a sec. Amron, can you answer that again? Do you understand what I'm saying?
Yes.
Okay, so you're still capable of getting your mark improved. Okay, that's still an option. The only thing is I can't give it based on your scores of your assignments, but I can give it on what you turn into me. I can adjust the mark if I think you've done the effort and you handed in everything up to this point, and it looks like you're getting, let's say I think that you're getting 90% of the mark, then I have to raise your mark up. Okay? It's still a gray area for me. I just got this email yesterday and I still don't understand it in its entirety, but I'm going to do the best I can. Okay?
Yeah. All
right, so I don't know.
Why did they decide to do it this way instead of how it was being done?
There's a few questions I'd like answered. That would be one of them, Amy. If I were to answer that question, I'm just gonna shut the YouTube off here, just because